Hello everyone, thank you for joining us today. New meetup, Madrid-Gug and Madrid-Yug. The first thing we want to know if, well, the slides are in Spanish, but we are going to give the talk in English. So we want to know if there are people that is the first time that they come to Madrid-Gug or Madrid-Yug. Can you please raise your hands? Okay, a lot of them. So welcome. We are actually two groups. I'm Ivan from the Groovy user group, and David is Auri Gonzalo from the Madrid Java user group. We've been doing talks together for the last, pretty much the last year. This is the first talk in this new season. And you have there our Twitter, Mastodon, Meetup, URL, so you have plenty of ways to contact us. And if you want to give a talk at our group, just ping us. We always say that you don't need to be an expert to give a talk here. Maybe you just need to basically tell us about something that you know, that you work on, and it's related to the JVM, Java, Groovy, anything related to the JVM will be welcome. So don't be shy, we are a small group. Also today there is a lot of people. And that's it. Thanks our host Thelonis for hosting us today. Now it's your turn, Alex.
Thank you, Ivan. So thank you everyone for coming, and especially to David, Ivan, and Teresa for this great session that we're going to have today. So as you see, this is our headquarters here in Madrid. It's a big building. It's kind of new. We started last year. And you might be wondering what is Thelonis doing, no? So we are working in process mining. Process mining is a new software category. And we help companies to improve their processes when they do something, no? We analyze the events that they do when they are doing some sales or some process that they do, no, because we can work on any kind of industry, and we help them to improve them, doing less steps. So by doing less steps to reach the same goal, they can save time, so they can reach to the customer sooner than competitors. They can also save on pollution because they are doing less carbon to the atmosphere and these kind of things, no, and of course they can save time, no, and save money. That's what we do. We also do coding here, no? This is one of the engineering headquarters that we have. We are around 73 people doing front-end, back-end, of course, data analytics and these kind of things, no? So if any of you is interested, so we will be around. We can do some networking later and tell you more about what we do exactly, no? Some important things. There is the bathroom, that door there, okay? And we will have later on some drinks and food and networking here at the right. If you want to leave the building, just look for me or for someone from the organization, and they will help you to find the exit door, okay? So thank you very much, David.
So, hi, good evening, everybody. Guys, let me, the easier part of the introduction is to introduce Trisha. I think everyone here knows her, and if you don't, you should, because Trisha, Java champion and a very good, I would say, Java influencer today. So if you don't follow her, just do it, because she said always very interesting things. So that's it. Thank you very much, Trisha, for coming here and for the talk.
Thank you. I have my own one. Hello, thank you. I've got to get my slide deck up now. I feel a bit like a lot of pressure of expectations on me here. David has been trying to get me to come to Madrid for 13 years or something. And I live in Seville, which is a 2-hour train ride away, and this is the first time I've actually managed to do this. So yeah, I'm here. Great, it'll be another 13 years before I come back, so make the most of it. Yes, and and the talk will be in English, but if you want to ask me anything in Spanish, you can. However, everybody knows me, I famously don't speak Spanish, but I do listen to it, so that's fine. And if I'm not allowed to give my first presentation in Spanish away from the Seville jug, they will kill me, so I need to give my first presentation in Spanish in Seville. So yes, and I also speak very quickly, so I'm very sorry, so if I go too fast, just say, help, I can't understand what you're saying. Today I'm going to talk to you about developer productivity engineering and what it is and why it's applicable to developers. Quick show of hands, I assume we're mostly developers and techies here. Great, awesome, good, you're the right audience. So yes, so I don't really need to introduce myself because that was already done. I've been basically doing Java for 20 odd years, and I've worked in a lot of different places doing lots of different types of jobs. I spent sort of 7 years at JetBrains doing IntelliJ IDEA stuff, and then this year I moved to Gradle. But the year in between being at JetBrains and being at Gradle, I wrote some books. So I brought some. I can't decide whether to raffle them off or just like make you run for it and see if the most excited person gets it first. So I've got 3 books to give away. And I've also got some Gradle t-shirts too. So because we're here for the conference, we've got some cool Gradle t-shirts. So now I've bribed you sufficiently, I should get on and do the talk, really. So I want to talk about developer productivity. The sort of theme of stuff which has been going through a lot of my presentations, a lot of my work in advocacy has basically been around developer productivity. And what I mean is like this sensation of like, I made the computer do what I wanted it to do, and yay, you know, it compiles, and I printed hello world. And a lot of us, when we first got into programming, probably it was this sensation which kind of made us want to become programmers. The reality of our day jobs in a lot of the organizations we work for, probably not yours, because you've probably got perfectly normal, sane organizations where everything is fine, right? The reality of a lot of jobs, especially when you're early on in your career, is that this is not what happens. You don't tell the computer what to do and instantly get a response saying, great, it worked, hello world, or whatever. Quite often you're waiting for the build to run and the tests to run and the deployment and the something, and then your tool chain kind of lets you down in some way, and so you spend a lot more time going, why am I doing this? And I've had quite a lot of jobs like that, which is why I ended up coming into developer advocacy, because what interests me is how do we get rid of the toil and the hardship and the blockages and all the rubbish around programming, and how do we make the job the one that we enjoy doing? How do we get rid of all the crap, really? And that's what I was kind of doing when I was talking about IntelliJ IDEA and Java, because I was like, look, this is cool stuff which makes our job easier. And that's kind of why I've moved to Gradle, because my job here is not about talking about the Gradle build tool, but about developer productivity engineering and how you can kind of help use automation to ease some of the pain in your day jobs, hopefully. So this is actually a good day of coding. When I say a good day of coding, it's because it's a whole day for code. There's no meetings, there's no travel, there's no interruptions. It's actually a coding day. However, even despite the fact that it's a coding day, you know, you might spend a couple of hours writing some code, and then you might have to wait for your local build to compile and run all the tests, and then debug any build or test failures, and then go to lunch. Perhaps you kind of set off like a big build before you go to lunch because it takes a while to run. Then come back, write some more code, and maybe this time you get to check it in, and then you have to wait for CI to run everything, and then you have some test failures, but they don't look like your test failures. And are they really test failures to do with you, or are they flaky tests because it kind of runs on my machine, but is that a function of the tests or my code? And so we spend quite a lot of time in this sort of backwards and forwards. We don't, even when we have a good day for writing code, we don't spend that much time writing code. We spend a lot of time like gluing stuff together and digging into why the stuff is not working the way we want it to. And in fact, a recent survey says that we don't spend all our time writing code anyway. We probably spend 32% of our time writing code, 23% of the time meetings and stuff, and then some miscellaneous stuff called code maintenance, which I think code maintenance is like stuff that I do that's codey but is not writing code, so I'm going to call it code maintenance, and testing, which is part of this, by the way. This is not 2 separate activities, it is the same thing. I mean, even then I think it's generous, because it still means that you've got 44% of time writing code rather than having interruptions, and I don't think that's realistic for a lot of us. Who thinks they spend more than 32% of their time writing code? Literally no one in this room. Who thinks they spend less than 20% of their time writing code? Okay, so the 30%-ish is probably about right. But even so, we're hired as developers and we spend a third of our time writing code, which is probably not optimal for our organizations, but for us, because we like writing code, I hope. So there's this quote from this guy from Dell. It says, bottlenecks in the tool chain are holding back the rockstar 10x developers. And so a lot of this talk, I'm going to talk about what I mean by bottlenecks in the tool chain, but I want to take a minute to talk about rockstar 10x developers. Because I've been working in the industry for about 10 years, and I'm not really sure I've met that many individual 10x developers. I've met some good developers, don't get me wrong, but like I don't think there's like developers and then a 10x developer, and then, I just don't really think it works that way. So we're going to dive into the myth of the 10x engineer, who, is kind of in the realm of El Chupacabra and Chulicornios, as my children call them. So where does this 10x engineer idea come from? It's possibly from the book Peopleware, or it's around about this time, sort of late 70s, early 80s, people start to do studies in productivity of engineers and programmers. And as part, when they were writing this book, these guys they ran a study called the Coding Wars. And what they did is they take two engineers, they get them competing to complete a task, and then they kind of figure out, like, who's the best one, and look at the things which make the programmers better at what they do. The way they did it is the two engineers would be from the same organization, and they would be using their usual hardware in their usual office, in their usual environment. And it was run across multiple organizations, but when they were paired together, it was always from the same organization. And they found that the best programmers outperformed the worst by roughly 10-to-1 ratio. So this might be where this 10x engineer thing comes from. However, there's a bit more to it than that. It turns out that the two programmers working on the task performed at more or less the same level. Now, it's important to remember they weren't collaborating, they were competing. But what they were is they were from the same organization. So the thing that they had in common was the fact they're from the same organization, working in the same kind of environment, and they perform at the same kind of level. So it turns out it's not necessarily the best programmers are 10x better, it's the best organizations are approximately 11 times better than the worst organizations. So this focus on the individual developer may be misguided at best. There was another study done around about the same sort of time which said, there's also a 10-to-1 difference in productivity among some software organizations. Now, this is the early 80s, so it's been like 40 years and people keep talking about the 10x engineer, and no one's really been looking at the 10x organization. The onus has been on us to prove that we are those 10x engineers, instead of the focus being on the organization, saying, what can we do to make our engineers 10 times more effective than our competitors? And this is the important thing, especially because you're talking about a team of 10x engineers, not one individual 10x engineer. And the productivity performance improvements from having a whole team who perform 10 times better than your competitors, well, that's a bit more interesting. So the conclusion from Peopleware was, the bald fact is that many companies provide developers with a workplace that is so crowded, noisy, and interruptive as to fill their days with frustration. That alone could explain reduced efficiency, as well as a tendency for good people to migrate elsewhere. So we're talking about two effects. The environment that you work in, the hardware you use, the amount of meetings you have, the surroundings that you have make you less effective if it's noisy and interruptive. And on top of that, if you have that kind of environment, your best engineers who have more options, they leave because they're not going to work in these environments. So your team becomes a less effective team. In Peopleware, they just kind of basically found, again, this is in the 80s, they found that those who performed in the first quartile have more space, more quiet, more privacy. They can silence their phone. What a crazy idea, silencing your phone. Can divert their calls, from a phone that was on the desk, like in the olden days. And they have, the more effective people have fewer interruptions. So to me, there's a big difference here between 38% of developers who say they get interrupted versus 76% of developers who get interrupted. And it's these kinds of interruptions which ruin our creative flow and mean that it's very difficult for us to, in that 38% of the time we have to do coding, we're being interrupted 78% of the time. We have about 3 seconds to think of an idea before it goes poof out of our heads, right? So we need to be talking about the developer experience. That's basically what this comes down to. Productivity is about the experience of individual developers and what can we do to give them a better experience when they're working on their day job. So then this is what we want to talk about. This is developer productivity engineering. It's a practice that Gradle's trying to pioneer. We've got a DPE summit next week where we've got loads of people talking about how they're doing DPE. I can't remember who's speaking this year, but we've had people like Netflix and LinkedIn and Spotify and DoorDash and other Silicon Valley people. So this is this practice of trying to maximize developer productivity by looking at the things which are getting in our way of getting stuff done, things which are interrupting us, things which mean that we end up multitasking, and we all know how good we are at multitasking. So I want to give you a look now at what I mean by DPE. The problems that DPE solves are mostly around trying to reduce this feedback loop. So coming back to the idea of the build and test cycle, these things which kind of, for example, if your build time is 20 minutes, you're not doing anything during the build time, you're kind of waiting for it to build, or you're doing something else and then you're not doing that properly because you get interrupted by the build finishing or whatever. So DPE is about reducing these feedback cycle times, trying stuff like manually, and so that we're not just having needless work and toil. So if you imagine an individual developer with a whole bunch of long things they're waiting for, or stuff that's flaky and inconsistent and breaks all the time, and you multiply that by the number of days in the year and the number of developers in your organization, you have much lower productivity and much higher cost if you've got a lot of this, seemingly unimportant stuff happening at the level of the individual developers. So the argument for DPE is that it's the next thing to be looking at after, DevOps and change. So I graduated in the late 90s because I'm old, and I worked at Ford. And Ford obviously doing just-in-time manufacturing. The Ford IT organization used to be called Business Processing Re-engineering. We were doing change management. We were doing Lean Six Sigma. I left Ford to go and do Agile. And I worked with Dave Farley when he was writing the continuous delivery book, which was kind of DevOps. So my argument is, I did all of this, and now I'm doing DPE, so that's definitely the next thing that you should be doing. That's my excuse, and I'm going for it. So all these things that we've been doing, DevOps and Agile and all that stuff, that's all great, and DPE is not to replace any of that. It's the next thing to try and find the bottlenecks and the friction and the things which have been getting on our way, which haven't necessarily been seen yet. So one of the things I like about things like continuous delivery and DevOps is that it really helped reduce the impediments between I've written code and I want the user to get their hands on it. So it kind of helped with all these pipelines and being able to break down the barriers between us and the user. But what we haven't really looked at is, hang on, when we're writing our code, is there still stuff here that we haven't really looked at yet, which is causing us problems? And it's not necessarily visible because we don't have observability on that because it's on our laptops. It's not necessarily in a CI server, or it's not necessarily monitored in production. It's just something that we kind of put up with and deal with on a day-to-day basis. So a 10x organization should be reducing build and test feedback times and improving the consistency and reliability of builds. So this is two things. One, reduce the feedback cycle time. And two, when you get a result, a green or red result, it should be something you can rely on. So did the build fail? Then it's probably failed. Am I going to rerun it again to see did it really fail? Because that's, then we don't have any trust in our tool chain. So we want short cycle times, and we want to be able to trust our tool chain. That's going to help us accelerate and move faster. So I'm going to look at some ways that we can do this. One of the pain points that developers have is around waiting for builds and tests to complete, so the build cycle and plus running all your automated tests. Is anyone here tracking how long it takes to run the build and test cycle on your local machines? Is anyone doing that? Okay, that's sort of fairly normal, 5% of the audience is perhaps doing that. How long does it take to run the build and test cycle? Who's got one longer than 20 minutes? Okay, that's good. It's not most of you, that's good. Longer than 10 minutes. And I know the answer is going to be it depends, because maybe some of you are working on multiple projects. But longer than 10 minutes. Longer than 5 minutes. Okay, oh right, okay. So 5 to 10 minutes is the majority. What about 2 to 5 minutes? Okay. Pretty reasonable. Under 2 minutes. No one. Okay. I mean, that sort of distribution. Oh, and who's using microservices or smallish services? Okay, fine. So I think that's fair. Oh, and who's on a monolith, like a big fat monolith? Didn't you just say yes to both? Okay, fine. That's fine. Because with the monoliths, we often see these really big build times and big test cycles. So here's another good business book, The Goal, which I have not read, but don't tell anyone. And The Goal popularized the theory of constraints. And the theory of constraints states that the only initiatives that will positively impact performance are the ones which will increase throughput while simultaneously decrease cost. Why is this important? You think about the ways that organizations are trying to streamline, particularly at the moment, perhaps maybe by laying off developers. That does decrease cost. Does it increase throughput? No. Does it stress out your developers? Yes. Do you still have the same amount of work to do with half as many resources? Yes. So things like what you want to be doing to improve the performance of your organization and to optimize it is to look at how to increase throughput. And it's things like reducing these build cycle times. It's things like being able to automate as much as possible to get stuff out there. And that will reduce cost. So for example, this was a real case study. The first team has 11 developers. Their build time is 4 minutes, which I think is pretty reasonable, actually. So in a week, the number of local builds they can do is 850. Okay, so seems pretty reasonable. Team 2 is half the size, it's 6 people. Their build time is 1 minute, which is pretty quick, let's face it. So with a 1 minute build time and only 6 of them, they can run over 1,000 builds a week. So by reducing their build time, they can increase their throughput. They can check more frequently, did anything go wrong? Does everything work? Am I more secure and safe in pushing stuff out to production, even with a smaller team size? And like a 4 minute build time, there's nothing wrong with a 4 minute build time, it's great. But you see the significant impact between 4 minutes and 1 minute, and that's in a small team size. Now multiply that over these large organizations, and you can imagine starting to see a lot more efficiencies if we can just drive down that build and test cycle time. And so why do we care about short build times? Why do we care about fast feedback? Well, it turns out that if you have faster feedback cycles, you get a whole bunch of good outputs from that. So for example, faster feedback cycles, you can build more often, so you get smaller change sets, fewer merge conflicts, more efficient troubleshooting if you do get any merges, faster, oh my goodness, I can't remember what that means, faster mean time to, yeah, I don't know, faster stuff. You can push stuff out faster. You can do stuff faster. So if you can get your code out faster and you've got fewer merge conflicts, you potentially got better quality because you've got less crap going on down here, and more productivity because you're pushing stuff out faster. Also, if you're building more often, earlier quality checks, fewer expensive downstream incidents because you find it earlier, better quality. If you've got faster feedback cycles, less idle wait time. For me, it's not so much about the wait time, it's about the context switching. Because once it gets over like 5 minutes, you go and make a cup of coffee or do something else or check your email, and then everything, like the whole tower of cards in your head is like done. So less context switching, more focus. More focus means better quality, improved productivity. So there's no downside to decreasing these feedback loops, to being able to get much faster feedback from the changes that we're trying to make, to get the results of our tests quicker. And the solution is a series of acceleration technologies working together to give us those faster feedback loops. I will go into all of these throughout the rest of the talk, but so we're going to talk about the build cache, predictive test selection, test distribution, performance continuity, which is basically visibility over what your performance is and is it getting better or worse. And use all of these together, you end up reducing your build and test feedback cycle time. So let's look at build caching first. Build caching will speed up your builds and tests. Ooh, a demo. Ooh, is my demo ready? Okay. So what I'm going to do is, did I take out a slide here? Gradle Enterprise, so I didn't really talk about what Gradle Enterprise is because I don't want to sell you Gradle Enterprise, but Gradle has Gradle Build Tool, obviously. It has another tool called Gradle Enterprise, which works with Gradle, Maven, Bazel, SBT, and it provides some functionality to the build tools, which we'll see. One of them is a build cache for Maven. So if live demos, what could go wrong? Especially with this resolution. Can you see anything? Let's look for what was already there. Okay, so I built this earlier on because, can you see it? So this is a Maven project. Let me talk you through it. This is a smallish Maven project. It's got multiple modules. So we've got multiple modules here, but it's not huge. It's not, I was working with Camel, which is 156 modules. It's not that. It's got like, I don't know, 8 modules. Fairly classic Maven project. The tests are, it's an object document mapper for MongoDB. So some of the tests are integration tests and they do need Docker to run. And so running the whole test suite takes 4 minutes and 10 seconds to run all the tests over that, which is kind of reasonable. It actually used to be 90 seconds when I first started doing this demo. And then they introduced test containers and now it's 4 minutes. So I don't really know what to say about that, but they do have better isolation now they've got test containers, but it runs slower. So what I want to do is I'm going to do a live demo. What could possibly go wrong? I'm going to add the Maven, the Gradle Enterprise plugin for Maven, and that's got a build cache, and we'll see what happens when we run it with a build cache. What could possibly go wrong? So I want one of these. So we're going to put a Gradle Enterprise XML file in here. I'm going to point it to my Gradle Enterprise server, which happens to be like an EC2 instance. And I need this. Extensions. Okay, and in theory, and that will just add the local build cache. It happens to be using Gradle Enterprise 2, but the point is it adds the local build cache. So let's see what happens, even if we run it with a clean. Let's see if it works. I just have to stand here for hopefully only seconds for it to run. Obviously, I've not made any changes. So if it is caching stuff into the local cache, you know, it should be able to just retrieve those. The point about a build cache is if your inputs are the same, for example, your source files or your resource files, the outputs should be the same. So your class files should be the same. So there's no need to recompile everything if you've already compiled it once. So if all your inputs are the same, the outputs are the same. So there we go. So the 4-minute build time is down to 18 seconds. Now, I didn't have to compile anything because by definition, I was using exactly the same source. But there's a multi-module project here. So if you make one change to one line of code, you don't have to recompile everything, which Maven usually does. You only have to recompile the bits that are impacted by that. So with a build cache, you can really speed up your builds. So the reason I was playing with Camel is a big multi-module Maven project, and it's got a build time of about 20 minutes without running tests, which is terrifying. And using the build cache, we can get that down to 3 minutes. So that's a big saving. One of the reasons why I like showing the Maven projects is, one, because we support Maven, we're not just like Gradle, and two, you get really significant savings with Maven. Because Gradle already has parallelization and build caching built in, so it's not so exciting to show that because it's already there. Okay, so build cache is going to, that demo worked, it was amazing. So a build cache is going to speed up your build and test cycle, particularly if you haven't made any changes or you've only made a small set of changes. Introduced the Java world by Gradle. And the interesting thing about build caching is you can have a local cache or a remote cache. So I just showed you the local cache there. Now, imagine your CI environment is building your code all the time, right? Your CI environment is producing class files right, left, and center. If in the morning I come in and I want to check out the most recent commits and the latest version of the code, usually what I have to do is do a full clean build just to make sure it works on my machine, right? But if there's a remote cache, CI will populate the remote cache with all those class files, with all the outputs of the build and the outputs even of the tests. And so then when I come in and check out that commit, and then I run build, it just gets all the results from the remote cache. I don't have to build anything. It's all there. So especially when you've got like round-the-clock developer teams, this can be really effective and save you a whole bunch of time. It's not just saving time for you, it's saving time for everyone on the team. So multiply that by everyone. You're starting to see a lot of significant savings in your time and energy and general stress levels. So build caching, it's just like any cache. Provided the inputs are the same, your class files, your resource files, your whatever, given some operations performed by tasks or Maven goals, then the outputs, they should be the same. There are some caveats, like if you're generating random numbers, particularly for tests, or if you're using things like timestamps, again, usually in tests, or there are some things around like class files, locations, paths to files and stuff, where it's going to look like the inputs are different, like generating timestamps when they're not. But you can, with Gradle Enterprise specifically, you can kind of say, don't worry about this, don't do that. So you can tweak your caching. But the camel example I was talking about, even before I didn't do any of the weird stuff to make the caching more effective. It went from 20 minutes to 3 minutes without doing any of that. And it was doing file generation, and it was using timestamps, and it was using strange file paths and things. And we still got great performance just out of the box. Right, so, the remote cache, I did it out of order. So then you can have the remote build cache, and it's really good, and you should buy it, definitely. You don't have to buy these things, by the way. Test distribution is about parallelizing the test execution. So that's all fine for like compiling, and even for looking at if the test results have changed or not. For our build and test cycle, maybe like 80% of the build and test cycle is the test bit. And so that's something that perhaps we would like to speed up, because minus skip tests is not an option. We are supposed to be running the tests. I'm looking at you, I know you all do it. You could chuck it into CI, that's what CI is for, that can run the tests. When I'm talking about like locally, you might want to run all of your tests and not wait 25 minutes for all of your tests to run. You can parallelize the test execution. We did this when I used to work at LMAX. We wrote our own, I don't think we haven't sourced it, we wrote our own thing, which would, because JUnit has hooks for this kind of thing. We wrote a service which would look at all the tests that were supposed to be running in CI, and it would farm it out to various different agents which were running on laptops, on VMs, running on whichever machines were lying around and not really doing anything. So then when you're running the 40-minute acceptance test cycle, it would just farm it out to whatever was available, and it would parallelize it and bring the time right down. Gradle Enterprise does this too, but it's not just about Gradle Enterprise. You can find a way to use agents to run your tests in parallel. Obviously, there are some caveats, like if all your tests are in one file, you're not going to be able to parallelize that. So you do need to have also split up your tests in some kind of sane and normal way. I keep getting ahead of myself. I'm so excited about talking about these things. So you can go parallel a whole bunch of different ways. You can go parallel with Gradle, for example. You can run your Gradle build in parallel using all the available cores. And obviously in CI, probably you're running a whole bunch of stuff in parallel anyway, some form of CI fan out, whether it's, in one place I worked, we split it by function, so we had like 3 boxes for API tests and 8 boxes for UI tests, but you sort of have to manually split that up and farm it out. When I worked at MongoDB, we split it up in a slightly different way. We would have some set of agents for a given combination of MongoDB version and Java version and driver version. So then you farm that out and parallelize it that way. So it depends a bit on what you're doing, but CI fan out is a thing. People have been doing it for a long time. So looking at all these things together, build caching is great, but if things have changed, you still need to run the tests. Single machine parallelism is good, but you're limited by that physical machine. And CI fan out sometimes needs like some sort of manual tweaking, and also doesn't help you in terms of running your tests locally. So that's one reason why a lot of people push stuff to CI, right? Because you can run your tests in parallel up there, and you don't want to be running them on your local machine. But test distribution allows you to run your test suite locally and use all those agents on other machines so that you can run stuff in parallel. And so you kind of get the best of all worlds there. And generally speaking, like I said, as long as your tests are sliced up in some sort of sensible way, which is as in a normal way, not a weird way, as you add more agents, so doubling the number of agents will halve the amount of time things take, because this is running in serial, and this is once you've got 2 agents, it will take half as long to run it, and so forth. So we've got a really nice case study from Netflix, and they reduced a 62-minute test cycle time to 5 minutes by using test distribution. So just farm it out over a whole bunch of agents, and it will run much faster. And then, AI is a cool thing. Everyone likes AI. So let's do some machine learning. What can we use machine learning for? We can use machine learning to help figure out which tests we want to run. There is a thing called predictive test selection. This link is a white paper released by Meta, by Facebook, about when they kind of invented predictive test selection. So Facebook has this enormous mono repo, and what they were trying to do is figure out, like, do I really need to run all of my tests every time I change like one line of code? So they did a whole bunch of studies on, can we do like dependency analysis and figure out which tests are most appropriate. And they found a fairly simple machine learning algorithm which will look at, given the changes, given these lines of code that changed, in the history of all the builds, which tests are most likely to tell us if this is okay. So effectively, which tests do sometimes fail if we change these lines of code? Let's run those ones. So it uses the history of your changes and the builds to figure out which subset of tests to run that will give you a pretty good idea, a 95% good idea of whether your changes were effective. Most helpful for local builds, obviously, because what you want is a kind of sanity check. Probably when you're doing your merges and your release builds, you want to run everything. You don't want to be like 95% certain it's probably fine. But if you're a local machine, 95 to 98% certain is pretty good. And it generally means you only have to run about 30% of your tests. It depends, obviously, but these are the sorts of numbers we're talking about. So when you use all of these things together, you start to see this acceleration effect of everything. So if you're using your build cache, then you don't need to rebuild stuff that hasn't changed. So you're already reducing your cycle time. Predictive test selection means that you are only running 30% of your tests instead of all of them. Now, those 30% of your tests, you're going to distribute them over multiple agents, so you're going to spend even less time running that. And performance continuity is something we'll talk about, but this is, again, the visibility over all of this. Like, what is our performance of our build and test cycle? What's happening with test distribution and predictive test selection, and is it still doing what we want it to do? You have to close the loop. You can't just do this and go, we're done, everything's fine. You have to keep doing this because things change. So I don't think I'm the only one to have asked our team, like even years ago, is the build and test cycle fast enough? Is 6 minutes fast enough? Like, yeah, it seems kind of fine, right? It's probably fine. But it's not the right question. We should instead be asking ourselves, is the build and test cycle as fast as it can possibly be? Now, it will never be as fast as it could possibly be, but that's where you're aiming for. You're not aiming for, is it kind of fine-ish? Yeah, it's sort of fine. No, you're aiming for, is it as fast as possible? No, obviously not. What's the next biggest thing that we can do which will take us that step closer to as fast as it could possibly be? And it's a moving target, sure, but like we don't just sit around with our code absolutely fine. Well, I wrote the application, it's fine. No one wants any changes ever to the app. Like, there's never any bugs. It never needs changing. No, we're always changing our code, and we need to be always looking at, keeping an eye on our build and test cycle time as well. So the next pain point I want to look at is inefficient troubleshooting of broken builds. And this is really about observability, visibility over any problems in the build. I found out something interesting the other day. I think it might be me that's broken. Whenever I have a problem with a broken build, a Gradle build or Maven build, like whenever I'm developing something, what I do is I sit there at my desk and like Google it and Stack Overflow it and bang my head against it until I usually fix it. It takes me a couple of days to figure out, what does this mean? Apparently what normal developers do is they ask a friend, hey, have you seen this problem before? Which is a really sensible thing to do, and I don't know why I didn't think of that. Either way, if you have a way of showing someone, this is my build failure, can you help me with it? That's much more helpful. Because if I've got a problem with my local build, you're going to ask your mate, especially if we're all remote workers now, you're going to ask your mate, like, you'll say something like, I got this build problem, and they're going to check out the same code and run the build and go, works fine, no problems. And they can't reproduce your problems. So you need to be able to give them a way of seeing what you're seeing. And for us at Gradle, this is the Gradle build scan. So it works for Maven and Gradle and SBT and Bazel. But this gives you a way of having a web page which says, this is my build, this is what happened, these are my dependencies, this is the command I ran, this is the operating system I'm on, these are the environment variables, these are the flags and switches. And then my friend can go, oh, I see, you're using Java 8, why are you doing that? That's the problem, right? You don't have to play this backwards and forwards game of like, what did you do, what did you see? So you need some sort of way of showing this stuff to people. You need some observability. Now, in production, we have this all the time, in theory. We have a way of seeing what's happening in production. We don't have a lot of visibility over what's happening on developers' machines. I don't mean spyware. I don't mean people looking over our shoulders. I mean some way of saying, I did this build, and this is what I've got. These are the tests that were run, and these were the dependencies that I had, and this is the infrastructure I was running it on. And share that with someone so that they can help you troubleshoot these problems. Particularly helpful if, for example, someone else owns the infrastructure you're running it on and you don't have control over that, and you say, well, my CI failed or my build in this box failed and I don't think it was my fault, it might be your fault, could you help me? And this sort of thing could be really helpful for that. And another thing you get, once you start collecting these outputs of the builds, like build scans or whatever, you can have a look at this information to start driving out some useful information to help make improvements. For example, you might see this one particular failure, this has been happening more and more over time. It impacts all of these different users and on these types of machines. So perhaps we should do something about that. Perhaps if we fix this one failure, we're going to see improvement to all of those users. They're all going to be unblocked and not come into this failure like, what is it? Apparently 300 times a day, right? I mean, it's a bit dumb because that's failing tests. So forget that says failing tests. Imagine it says something better, like can't connect to some sort of repository or can't download some sort of dependency. This might be something which is happening to your development teams right now. They might be running into the same problem again and again. But because each individual developer is doing it on their own and fixing it on their own every time, you're just getting these invisible problems which are slowing everyone down. And you have no way of fixing them for everyone because everyone's in their own silo. Okay, another pain point. This is my favorite. Flaky tests. Oh my God, I hate flaky tests. It's actually the reason I joined Gradle, because when they said that Gradle Enterprise had a flaky test detector, I was like, I'm in, what do I do? So, what happens when you run a build and it fails? What do? You rerun it, and then it fails. Oh, third time's a charm, right? And then it still fails, and then you push it up to CI anyway, because you're like, well, CI's got more resources, it might pass on CI. So you kind of just waste all this time, and because you don't trust your tool set, you don't really know if what it's telling you is the truth. And so you kind of ask, CI to run it or whatever, or get CI to automatically rerun it when something goes wrong. So there's a study done on the developer experience of flaky tests. It says that rerunning the failing build was, and it also said attempting to repair it, but I don't care about that. Rerunning the failing build is one of the most common actions. So you don't even look at the test. You don't look at the results. You just rerun it straight away. And that just means waiting for the build to go again. It means using resources, whether it's your brain or the resources on the computer. It also said, our findings also suggested that developers who experience flaky tests more often are more likely to take no action in response to them. Because, it's flaky. This one's that test that just fails, I don't know why, so just push it, merge it, no problem. This is why I hate flaky tests. Flaky tests are worse than no test because it's getting in your way, it's slowing you down, it's causing confusion, and if it really was failing, you'd be ignoring it anyway because it gives you no information about what the failure is. Like, it's probably flaky, but it could be actually broken. You could have broken something and you would be ignoring it because sometimes it's a bit flaky. So to me, it's worse than having no tests. And don't get me wrong, I do not like having no tests, but flaky tests are worse. So what you want is some way of tracking and identifying flaky tests. So you want one way of seeing, like, for each of these builds, how many failures do we get in the build, and like which of those failures are perhaps flaky. There's a few different ways of doing this. In Gradle Enterprise, what we do is we get you to turn on the auto retry on tests. So if a test fails, it should be rerun. So if you rerun it like 3 times, and it passes one of those, it's by definition flaky. It should not be passing, failing, passing, failing. Somewhere else I used to work, we implemented our own flaky test detector, and what that did is it would look at the results from Jenkins and go, well, this test passed, failed, passed, failed, passed, failed over history, therefore probably flaky. And so we then had a information radiator like that where we put the most flaky ones at the top and kind of ranked them by, it was actually called a Trish score, because the tool was called AutoTrish because I hate flaky tests so much. Someone wrote a thing to do what I used to do, which is I would look at the test results and go, this one's flaky, this one's failing, this one's probably flaky. And That's what your developers do if you don't have tools to do this for you. Right, so, and when I was working at this place, Dave Farley was my boss, and he's done a really good video on the 5 causes of test intermittency. So, once you've identified your flaky tests, I realized that by telling people you could identify flaky tests, I was giving people permission to ignore the flaky tests. Well, that one's flaky, so I'm not going to do anything about that. No, find the flaky tests, fix the flaky tests, please, or delete them. Like, just stop them being flaky, please, because they're just in your way. This is an excellent video, so I highly recommend it. I wrote a whole bunch of blog posts on it too, because honestly, it's just my favorite topic. These links will be available at the end. Another pain point, no metrics or observability. So here's what I was kind of trying to say. It's all well and good kind of putting in the work to make our build and test cycle fast as it could possibly be. But without keeping an eye on it, it will get worse. It just will. That's just kind of how things go. So we need a way of seeing what our build times are and having visibility over it. Entropy basically states that things are just going to get worse if you don't do anything. I have a bunch of projects that I don't really do anything with. I use them for demos and then I park them for like a year. And when I come back to them, they don't work. And I'm like, nobody has worked on this thing. How could it not work anymore? But just stuff changes. Stuff just gets worse unless you actively work to make it get better. So, right, I don't have any pictures of this, but anyway, Mike Nygaard in the 2nd edition of Release It, he says, the tools, services and environments that developers need to do their jobs should be treated with production level SLAs. The development platform is the production environment for the job of creating software. Like, I really want to put this quote up here because I think this is super applicable. We as developers, we kind of get used to being told, well, you know, you can't have a better laptop because you're just a developer, or you can't have this piece of software because it's too expensive, or it's going to take too much time to automate this thing, so you're just going to have to do it manually. But you would never put up with that in production if it was the users. And you know, we need to be treating these things with production level SLAs. Like, has the build time, if we got the build time down to 3 minutes, and 6 months later it's back to 5 minutes, we need to be monitoring that and on top of that and say, does it matter? Should we do something about it? Because this is our production environment for producing the code that goes to production. We just can't have this like some crappy little desktop sitting underneath someone's machine, which has also been my experience. Final pain point, I should number these because I can never remember which one's the last one. Inefficient use of CI resources. So obviously, if you're going to reduce your build and test cycle times, if you're going to run fewer tests, if you're going to be spending less time doing builds, it might be tempting to think that you'll spend less money on CI perhaps, because if you've got, you know, cloud infrastructure, you should be using it less. That sometimes is the case. You do sometimes end up spending less money. That's great. What often happens is you use it more. So, which is not necessarily a bad thing. You still got the same set of resources. You're just doing more builds. You're doing more throughput. You're getting more for your money, basically. So you may not save money, but it will be a more efficient use of CI. You're not running all those tests all the time. You're not rerunning flaky tests all the time. You're not running compilations that don't need to be rerun because you've got the build cache. So you're making more efficient use of CI. You don't need to necessarily throw more money and resources at your build pipeline. In summary, 10x developers might be a myth, but 10x organizations really are real and measurable. Developer productivity, our productivity as developers, is linked to our experience, our everyday experience about the insane stuff that gets in our way and stops us from doing our jobs. If you don't do anything about productivity, your life won't stay okay. It just will get worse over time. It needs to be something that needs attention and care all the time. Fast feedback, efficient troubleshooting, and reliable cycles are key. The reliability thing often gets missed because it's easy to head towards speed, but reliability is almost even more important. You want to be able to trust the results of your build and test cycle. Start with observation and then take action on data. So I've given you a lot of information in this talk and thrown a lot of stuff at you, and maybe I hope you've got some good ideas on things that maybe you could do in your teams. The first thing to do is look at what's really happening. My suggestion would be to measure local build times. That would be the first thing perhaps. And then figure out, because you might think we don't really have a problem, we've got 1 minute build times, and then find out that actually what you've got is 10-minute build times and 1-minute build times and 5-minute build times, and or not, and maybe it's not a problem. But start measuring some things that you think might be a problem, like local build times or test cycles. Or something else I'd be looking at is, are developers just simply not running tests or not running the commit build on their machine because it just takes too long? These kinds of things. Because you might also find that once you can speed up the local build and test cycle, then CI gets less crazily bogged down with stuff, because if you can run it locally and you know it passes before you put it up to CI, then you're not going to put some buggy, test failing build up to CI. And proactively solve problems for the whole team. The thing I really like about DPE is it is something that helps everyone. If I fix one flaky test, that helps all of the developers. If we add a remote build cache for the team, everyone's build time goes down. This is how we get a 10x organization. Everyone gets raised up by one or two activities that helps everyone all at the same time. It's not about making that rockstar developer so much more effective. It's about small things that make us all more effective. And we did a study which says, of our customers, Gradle Enterprise customers, which said that 81% of surveyed professionals agree that DPE's impact on their toolchain makes their job more enjoyable. Now, this is the thing I think is most interesting about DPE. It's not about squeezing every line of code out of us poor, overworked developers. It's about freeing us from a lot of the crap we have to put up with so that we can do the creative thinking stuff that we really need to do as our jobs. It's not about typing, it's about space to think and to solve the problems. And that's why we need to get rid of a lot of the manual rubbish, because we need that space to breathe and think. And then, I want to say something a little bit about how can you sell this to your bosses. And it's actually surprisingly easy. I mean, depends whether the bosses listen or not. If you look at the pain points that we have, so developer pain points, things like slow builds and feedback cycles and inefficient troubleshooting. If you can fix the problem with slow builds and feedback cycles, you get faster delivery, which leads to increased revenue. You get improved productivity and resource efficiency, which decreases cost. If you can address the inefficient troubleshooting, you also get improved productivity and decreased cost, and better quality of service and an improved brand image. So these small things that we do to help reduce our build time, which seems like a sort of almost tech debt, doesn't really impact anyone thing, has a direct line input on C-level objectives. This is what your CTO cares about. So this is how you sort of sell it up to the business, if you want to sell it to them. Next steps. The slides are available at this link. This is a link to my blog, which has got all the slides. If you want to take a photo, do it now, because I'm going to press the thing. Great. And the other thing is, we have a DPE community which Gradle runs. You can join this for free, and it will lead you through some of the resources for developer productivity engineering. We have a free DPE handbook. We have a bunch of talks and presentations you can look at, some material, and it's not selling Gradle at all. It's about how you can get your team to be more DPE-ish. And the other good thing is, the more things you do on there, the more points you can win, and you can win like swag and goodies and Lego and t-shirts. And there's a little pillow with an elephant on, which I'm desperate to win. That's what I'm aiming for. And that's it. Thank you very much. Any questions? Yep.
Hold on a second.
Oh, we have to pass the microphone around.
You're speaking about developer productivity, but what is the most universal and objective metric? How do you determine that your developer is 10 times faster than?
Right, that's a great question. So I'm talking about improving developer productivity, but what do we mean improve it? If we're not measuring it, how can we see that we've improved that productivity? That's actually a very, very good question and a difficult one to answer. There are a few different metrics for measuring productivity. Some of the most recent ones I've looked at are more around sort of questionnaires and surveying the developers. How do you feel? Do you feel frustrated and blocked? Can you get stuff done in your job? Are you happier? And does anyone see anything about the new McKinsey thing which came out about how to measure developer productivity? Yeah, so don't do that. That's not. That's not the thing. So yeah, I mean, there's always metrics. There's always different types of metrics, whether it's like, you know, lines of code, or I've seen a bunch of organizations lately measuring developers' productivity based on the number of commits they do. And I'm a bit like, developers are not stupid. I can do more commits. It doesn't mean I'm more productive, right? So yes, it's difficult. The most recent stuff has been more around like, how do developers feel about it? When talking about developer experience, like what is your experience? How do you feel about it? Which is also not terribly scientific, but if you put it in a questionnaire, it looks kind of scientific.
Okay. But my personal feeling is that every time engineers invent new methodologies, frameworks, and another stuff to slow down the development.
Yeah.
Really.
Yeah, exactly. So new stuff will always slow you down anyway, because new stuff is always going to be something to learn. But yeah, more processes and more. One of the things I like about DPE is not a process. It's not something we have to think about. It's a set of tools that help us to speed up, and that's why it's a bit more measurable. So, for example, what we're measuring is feedback cycle time. So, if your build time was 10 minutes, let's say, we can calculate how much that's costing your organization. You have 200 developers, well, not on one team. On one team, you're 20 developers on that team. Your developer's average salary is this. If we can reduce that 10-minute build time to 5 minutes, we've just saved you X amount of money. It is literally a bottom line savings, because you know your developers are now free to do the work they're supposed to be doing.
Okay, thank you.
Okay. More questions? Yes. Oh, sorry, microphone.
Well, before this presentation, I thought that the smartest way to improve productivity was maybe there are two ways to do things: to play the same game smarter,
Right.
or maybe to play a smarter game.
Right.
I thought before this talk that playing a smarter game was really the most intelligent way to improve, but as far as I know, it's really hard. That requires a lot of imagination. Thanks. The most valuable thing for me is your talk has shown to me that making day-by-day things on a smarter way gives you a really big way to improve your productivity. I didn't imagine before that it was possible.
Thank you. I think you're right. I think that we've looked at, as an industry, we look at these big things. What can we do? We do DevOps and we do Agile and we change the way that we work. But I think that's why a lot of this stuff got left behind. We just kind of assume, well, a 15-minute build time is that we've always had 15-minute build times. That's kind of fine. But playing the game smarter is, okay, let's look at what we really do. Let's not change it fundamentally. What have we not looked at? Where are the blockages? Where is the time? What are we spending our time on? And sometimes it is literally like, buy everyone a better laptop. They're expensive, but again, developer salary, developer time, it could be a lot cheaper just to buy everyone a better laptop, and a lot easier than overhauling your whole processes or using a new framework or hiring a bunch of new developers. So yeah, good. I'm glad that you took that away. I think we do need to look at the small things. They all add up amongst all the developers and the team and the whole organization. It adds up to a big change. Any more questions or comments? Yeah.
Wait.
I have to wait for the mic.
So you've shown us the extension for the Maven, right? And it means that probably Gradle has it built in. There is a speed difference between the Gradle doing the same thing, or no?
So I do have a project. I can show you what it looks like in Gradle. It's, let's see, where is it? So there's two things. One, that's where I'm going to push my build scan to. So that's my Gradle Enterprise server. And then there's another property where you say caching equals true. So you can turn on the caching without having Gradle Enterprise or anything. Just if you're using Gradle, you just turn on the local caching. I can't remember what that flag is. It might be, I don't know. It's in the documentation. The speed improvements, I mean, it depends a little bit. My Gradle projects are generally a bit smaller and pretty quick anyway, so you do get speed improvements, but you know, half of 1 minute is 30 seconds as opposed to half of 20 minutes. So yeah, but I spoke to a big bank in London last week, 2 weeks ago, and they were using Gradle, and they've already done everything that they can do with Gradle for free without using Gradle Enterprise, including local caching. They even built their own remote cache. And so for them, like buying something like Gradle Enterprise, there wasn't a lot of point because they already had small microservices. Their build times were generally 2 minutes or so with local caching, and they were playing with remote caching. But I think what's interesting in some of those cases is test distribution and predictive testing. But again, like if your tests only take 2 minutes or 1 minute, you don't necessarily need to do that. Does that answer your question?
More or less, yes.
More or less. Just rambled around the topic.
Thank you.
Anything else? Or we all want, do we get drinks? Is drinks a thing?
Yeah, no, we need to close.
Oh, questions on the live stream.
It's by. No, there's no need because they already have it. It's by Gero, and he says, first of all, great talk. And the question is, could you recommend any specific tools for monitoring dev local KPIs out of the Java world?
Gradle Enterprise. So he wants to monitor the like local build times and stuff. Was it local build times?
Local developer KPIs.
Right. I mean, that could be anything, right? Yeah. I mean, we actually have a blog post on how to measure local build times, for example, without buying Gradle Enterprise or anything. You can build hooks into your build tool and have it report data to whichever server you have collecting data and events and stuff. So you can build your own sort of thing for that kind of thing. But I think one of the reasons why DPE is interesting is because it's not a super mature field right now. There's not a lot of people sort of looking at what you're doing on your local machine. It's also a bit of a fluffy area because it's not managers checking that your mouse is wiggling, right? And so it gets a bit, so that sort of productivity I really hate, like, because if you're trying to fix a problem, you're not wiggling the mouse, you're probably staring at the wall thinking what the problem is, right? So it's a bit of a hazy area in terms of measuring remotely what someone's productivity looks like, which is why the build and test cycle is a nice, easy one to look at, because we should be running builds regularly, we should be running the tests regularly. It's part of our commit phase in theory, and if we can improve that, then we know that we're improving productivity. I hope that answers his question, because the answer is no. Okay. Then I think we're done, right? Yeah, thank you.
Yeah. No, the slides are fine.
Oh yeah, but it was. Where's my sharing gone? I've got so many things here. Oh, what's stealing my screen now? This happened to me the other day. Oh, there. That's why.
Can you share?
No, don't close it. We're
Don't
going to
close-
continue with the slides.
You're going to continue with the slides?
Yeah.
Okay, fine. So, fine. Ta-da.
Okay.
I don't know if I'm not sharing, am I?
No?
Nope.
Oh, okay.
Now I need to...
StreamYard.
I know, but it's not letting me in. Probably because it's full, was it still full screen? Oh, it's usually Zoom that does this for me. Oh, there we are. Present. Share screen. Share screen. Allow.
Ahora sí, David. Okay. Okay, we are going to close the session. Thank you, Trisha, for the talk. So we have, as I said, we are starting a new season, and we said the same last year. We try to have one meetup per month. And this is the first one, and we just have a new one next week. So we are trying hard, but it's complicated because probably you know next Tuesday they are going to release Java 21. So we are going to have a talk about Java 21. So instead of having one speaker talking about Java 21, we decided to have a multi-speaker talk. So basically, we are going to have like small lightning talks, like 5 to 6 minutes, speaking about the new features of Java 21. So there are like 10, 12 features, and a bunch of speakers are going to talk about that. So it's going to be next Tuesday. The meetups are already there. You can join, but we will announce them tomorrow. So if you are here in Madrid next week, please join us because it's going to be fun to talk about all the new features in Java 21. Okay, more things. We have tickets, free tickets for API addicts. It's on October 3rd, and we have 5 tickets, free tickets for the conference. So now in the raffle, if you are interested, you can raise your hand, we can put your names, and you may win one of those tickets. We also have one JetBrains license and one Madrid Good Mag, not that one, that's Trisha, I have another one. And we have books. So instead of
T-shirts.
And t-shirts. So instead of running for the books, we are going to raffle them so nobody gets hurt. What else? We have an open collective. This is for the Madrid JAG. We have another one from Madrid Book because basically we are a non-profit thing, right? We don't make money, and we do this because we want it. But we need some kind of money for the StreamYard, for the domains, for the meetup. So if you have some money, if you or your company want to sponsor us, you have there the Open Collective. If you don't know Open Collective, it's a nice thing because basically we don't need to deal with Hacienda, which is kind of a mess, right? You don't have to want any problems with Hacienda. So everything is legal. You can get an invoice, but we, the organizers as persons, we don't get the money. They get the money for us, and we upload an expense, and they pay us, but they deal with Hacienda in our behalf. So it's a nice thing to do. And what else? Yeah, we've been showing this for a long time. We are running a Mastodon instance, JVM Social. So if you want to try Mastodon and you want to be in an instance related to the JVM and have a lot of people, Trisha is already in that instance, just join us. JVM Social, we have been running this for how long? Jose Miguel is basically the admin of the instance.
6 months.
6 months. We have an open collective also for the instance. Because yeah, it takes money, and you can see in the Open Collective how much money does it cost to basically to run a Mastodon instance. It's not a big one. We don't have thousands of users, but you can see the expenses because everything in Open Collective is public. And yeah, basically that's it. We are going now to finish the streaming, and we are going to do the raffle here only for the people here. So if you watch this online, you won't win anything, and if you want to have the chance, just join us in person as you are here. So we finish, and we hope to see you next week. Thank you.